Okay, welcome everyone to this continuation of AI for the working mathematician. The 2025 edition, so I really have to reiterate that this might change very, very fast. So it might age not well, and that's fine. If it doesn't age well, that's fine with me. Still, I would like to tell you a little bit about how to actually prove theorems with AI. Because it's kind of not true that AI can't prove theorems for you. It actually can. Yeah? Even as a working mathematician, when you want to prove new things. And I'm going to tell you a little bit about this. It's sadly mostly in an anecdotal way. So, very difficult word. What a mouthful. So there's not much research on it. There's a little bit of research on it. And I really recommend this paper, which I'm going to use later. So it's kind of very nice. When combinations of humans and AI are useful. That's essentially what we are talking about. So in 2025, you should really think humans and AI. Not AI and also not just humans, but humans and AI. And this is a really nice paper, which does a kind of a meta-analysis of the problem. And there's also a much shorter version published in Nature. So this is like 44 pages, and Nature has this page limit, I guess. So it's a much shorter version in the Nature one. But anyway, we'll see that later. Today, yeah, that's literally the point. What is proving AI in mathematics? And let me just fit the page. The slogan is, come on, let's just do it this way. The slogan is the following. So recently, with 2025, what recently means doesn't really matter. I was on a conference in AI, and Adam Wagner gave a really nice talk. And one slide stood out, at least to me. And I took a picture, and I used this picture as a guideline. So Adam is one of the authors of a paper which I'm going to pull up in a second as well, which was one of the AI breakthroughs. Here you go. AlphaEvolve, one of the AI breakthroughs in 2025, and Adam is like here. And I don't really understand the order they are using. They explain at one point in their paper who has done what. I don't care. So here's the paper, and it is a really good paper, and it kind of gives me a hint what I should expect, what AI can do for me, right? Not just what AI can do for everyone, which is much more important, but also what it can do for me. And the slogan I agreed with, and kind of everyone in the community agrees with, and Adam really, really nicely formulated here on this slide, and we will read that carefully, and I would like you to keep that in mind. And it's really about AlphaEvolve, but I'm using it more general. AlphaEvolve is a large language model type AI, and I'm kind of using it in general for what a large language model, what everyday AI can do for you. And Adam explains it as following. If we put 1,000 eager undergraduates in a room and give them this problem, I will show you an example of what this problem is, how likely is it that they will succeed? Yeah? And AlphaEvolve, so AI, is in 2025 like having, it's a really good analogy, like having 1,000 eager undergraduate students in a room who are excited to work for their problem. And what they can do really well is they will read the literature. Yeah? People nowadays don't read the literature anymore. AI is really excellent in reading the literature. And they try to combine all these ideas in very strange and crazy ways. Doesn't really matter whether they understand what they're doing. Yeah? And then they will zoom in into ideas that gives them a high score, essentially. There's some version of reward system. And you should really have this in mind. If there's a problem in mathematics that you can solve in this way, probably AI will do it for you. If it's more sophisticated, probably AI will not do it for you. I thought it was a really nice analogy. I really need 1,000 undergraduate students, I guess. I'm not sure where to find them, but I thought it was a really, really nice analogy, right? And I think AI in my everyday life, in my everyday research life, I guess, is this idea of exploiting this, right? So just try to see how we can use this strategy somewhere. And this was a really nice talk, kind of fun. Let me just tell you about a little story time, so you can kind of see it. talking lecturer MFO L1. So this was a joint conference of Matrix, which is in Australia, University of Melbourne mostly, and Oberwolfach, which is in Germany. And it was kind of a very nice conference where we had some talks live and some talks from Oberwolfach, and they had some talks live and some talks from us. It was really nice setting. Anyway, you don't really need to know that. I was just wanted to waffle a little bit. The point again, the slogan is, I think this analogy with the 1,000 eager undergraduate students actually works really well in the sense what AI can do for you in 2025. And let me give you an example of that. So here's from the AlphaEvolve paper. So let's do the hexagon problem. So the top one here. So essentially you have like 12 hexagons of unit length, say, and you want to find the smallest hexagon they fit into. And there's like an obvious solution if you want, and there's a more sophisticated solution. And this is some kind of type of the problems AI will be really good at, right? So this is kind of the problem where you imagine 1,000 undergraduate students could solve that problem in a very, very fast way, in a very, very efficient way. They could improve the known results, right? This is kind of the type of problem where, AlphaEvolve in this case, or our little undergraduate student thing can do very well. And I thought this picture, where they were building the pyramids, actually works in kind of the same way. So I really want to think of myself as being this person here kind of coordinating the AI, which is kind of the rest of all of them. And all of these people together, they achieved quite a bit. They achieved quite a bit in this case. Building the pyramids wasn't a small thing, but it kind of did all of that. And it's not just a lot of people, it's also good coordination. Yeah? So you have kind of both. And that's the task where I is like really good at. Repeat what I said. Essentially, it's on Adam's slide here, the second bullet point. They will read every possible paper they think is relevant. And 1,000 people can read a lot of papers very fast. Compared to one person, I guess. And they try to combine them in kind of crazy ways, right? They're kind of young people. They try things. If you're just old and you're just like, it doesn't work anyway. And you stop trying. So it's kind of cool. So AI will never give up trying crazy things. But if you try crazy things, just make me reiterate that, then also sometimes the output is a bit questionable. But you might discover something new. Hope that makes some sense so far. So I really like this analogy. That's why I pulled it up here. And I also kind of feel like this analogy with the pyramids is not so bad. You can achieve actually quite a bit if you just rely on this strategy of having a lot of people working together. Yeah. So really, working together is really important here, and also in some coordinated way. You need someone, in this case, a human, who knows where you want to go. Right? That's essentially what it is. And then you have AI, and it helps you. And it's kind of really cool if you want to read the AlphaEvolve paper. They solve problems of a similar type as the hexagon thing, and AI improved, essentially, the results on all of these problems by kind of a little bit. Yeah, that's what it can do at this point, which is pretty impressive, I think. But to be more hands-on, the way I use it is like the following. I will open the ChatGPT correspondence that I had with it in a second. But essentially, okay, I'm just using ChatGPT. I'm biased. I just like it the most, but you should be able to use anything you actually want in everyday AI. If you have something else in mind, it should be able to do the same. Okay, in 2025. So I asked a really research paper. I was interested in a certain lemma. And I didn't quite know how to prove it. It's kind of a loop, and so I formulated it. Doesn't really matter. We'll read it a little bit more carefully. And then it spit out an answer. And it tried to prove my statement. So first of all, it tried to, usually what it does, it tries to understand what's going on, and tries to take it a little bit further, and then it tried to prove it. And the proof it gave was okay-ish, but it was not correct. But it kind of sparked something inside of me, and I was like, that actually might work. And I was able to work it out. That's pretty good, right? That's a pretty good example of what AI does for me. You might argue that I would have found the proof myself. Sure, could have been, but it was pretty good. It just essentially gave me the correct phrase. It essentially gave me the correct prompt, right? It gave me the correct prompt so that I just had the idea and just fill in the rest. And that works really well. So if you are working on your thesis or whatever, and you're not using this strategy, I think you will fall behind. I really recommend that. So it can help you with localized tasks in this fashion. And I will show you now what it actually did. Essentially, it knows the literature and pieced things together, which is exactly what we have seen in the beginning. So that usually works in an extremely nice way. So here's my little conversation. I essentially had some sequence. Doesn't really matter what it does. And I gave some, I tried a little bit with a computer program and I just copied the code, what I was doing. And it thought for 3 minutes and 17 seconds, which is quite a lot, yeah? But it spit out an answer, it kind of rephrased the question, came up with something, and then made up a strategy how to prove this. And there were exactly the right keywords, like spectral representation and decomposition of something. It's pretty sophisticated, as you can tell here. And then blah, 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 blah. And then I kept on going and I was able to fill it into a proof. And what really happened is the following. So I had this problem, which you can think of as a combinatorics problem, a counting problem. And it realized eventually, let me see whether I can find that this is related to random walks. Yeah. So blah, blah, blah. Eventually it realized that this is related to random walks and like dig paths and ballot numbers. That's right. That's exactly right. And so it knows the literature very well. Kind of the fun thing is, I knew that as well, but I somehow forgot and I wasn't able to piece it together at that point. So it just made this discovery, which it got from reading the literature very well. Yeah? That's essentially what happened. And it pointed it out in the proof it proposed, and I was like, that could work. Yeah. So that's literally how you use AI nowadays, or at least how I use it. I think this is a really good example. It's just one example out of many. This was like super efficient. It literally just after like 3-4 minutes, I read what it produced, and it was really like, that actually might work. And that's pretty good, right? That's actually not bad. That's really not bad. And that's usually what happened traditionally if you were talking to your co-authors or to friends or to other mathematicians. Sometimes they just say the right thing at the right time and you just have the right idea. It was one of these examples. And you can use AI nowadays kind of more efficiently because you don't need anyone else. You can just do it whenever you feel like doing it. I think this is really good. The other type of examples that you will find is counterexample generation. So maybe you have a question, whatever, and you're wondering whether it's true or not. Then you might use AI to propose certain families. Here, whatever, you have some graph problem, it tries to generate some graphs and try to verify or disverify or disprove your conjecture. And if it finds a counterexample, your proof is done, right? So that's the whole point why finding counterexamples is so good. And it just essentially AI can generate something like a minimal counterexample, sharper hypothesis, something like that in a very, very efficient way. Again, because it has read the literature, whatever read means in this case, it knows a lot and kind of combined things in crazy ways, which might give you a new insight into a problem. And I feel like these two are kind of the main usages of AI in 2025 for proofs. Either like this, you have a small lemma, you don't quite know how to prove it, maybe it finds a fun connection and you can just exploit what is already in the literature. Or similarly, it finds a counterexample, it helps you to sharpen your theorems or something like that. And again, that works really, really well. Just to wrap up, if you're still skeptical, there is some research on how useful this is. Humans and AI. Now let me reiterate this in case it wasn't clear. I'm a big fan of this idea of using humans and AI, right? In both of my examples, the AI helped me to do something, and in the end, in this case, it helped to sharpen the theorem itself, for example, right? But I still did everything. not everything. I still did the final step. If I would have done everything, I would have not talked about humans and AI. That's kind of the interaction that I have in mind. And then there's this paper, When Combinations of Humans and AI Are Useful. It's very nice, very readable. So there's the arXiv version, and I think there's a Nature version, which is much shorter. So let's look at the Nature version for a second. This is only 14 pages, whatever. So Nature has a page limit. And they have this beautiful picture how AI, in certain sense, sometimes outperforms humans or human interactions, and sometimes it doesn't. Very readable paper, very short, tells you a lot about how tries to kind of systematically verify kind of claims around how effective humans and AI are together. And the big takeaway, I think, is the following. You should check yourself if you don't. You should never believe a random person on the internet, right? So check yourself. So the big one is, if a human is better than AI, yeah. So I'm better than AI in proving things. Yeah. If the human is better than AI, then teaming up actually boosts performance. That's the whole idea why I want you to do it. You will be better in proving than AI. Most likely, at least. Maybe not, right? Some people can't. But anyway, most likely you will be better than AI, and you can still boost your own performance. And the two examples I gave you fit exactly into that slogan. The paper says a little bit more, but this is like the big takeaway message I just cherry picked out of it, if you will. And that's exactly how I would like you, that as a working mathematician, you can exploit and guide your own intuition. That's what AI is good at. And why does it work? Again, because if you think about a proof, let's do one thing again, cherry picking. They often have literature reading parts where you could really profit from just knowing different ideas, related ideas from different fields. But nowadays nobody reads papers anymore. Fields get very tiny, and there are little exotic groups in those fields and whatever. So people don't read papers anymore, in particular not outside of their field. And this is what AI can do very well. And then there's still, I still like this picture for some reasons. I really still like this picture. And there's still this, the human, which is like making sure that everything goes in the wrong direction, in the right direction. This is how I really think about how AI can be useful in everyday mathematics. Yeah. So, and this kind of applies to all tasks. So usually, if you're already good at it, AI helps you to get even better. That's a bit strange. That's what evolution does all the time, right? So people who profit already will profit even more. It's a little bit sad, but in this case, that's how it can boost performance. So the paper will say a little bit more along the lines of the easy tasks, people who are not good at it will profit the most. Like a good example of what AI can also do is, if you're not a native English speaker and you need to write an email in English, AI will be super helpful for you. And that's not really helpful for a native English speaker, right? In this case, the underperformers, if you want to call them underperformers, I put that in quotation mark, you will understand what I'm saying. The underperformers will profit mostly from the AI for such tasks. And research is kind of on the opposite end. The overperformers will profit most from AI. That's at least what I have in mind. But really, as a takeaway, it's really just you need to polish what it does, and that takes a little bit of already existing insight. So what you shouldn't expect in 2025 is that you can just use AI and prove a fancy theorem in a field where you have no idea what's going on. That's probably not going to happen. Yeah? AI can boost your own performance, even when it comes to proofs, by just kind of selectively making AI read certain parts and help to improve what you have done. In particular, I say that again because it's kind of really important, and Adam pointed this out so nicely, so let's go to Adam. AI is really good in reading every possible paper, again in quotation marks, and combine ideas in crazy ways. Now, that's what AI can do right now very well. So if you think that that's helpful for your own research or whatever you're doing, then probably you should try to use AI. Anyway, I hope you enjoyed this video, and I also hope to see you next time.